So inevitably, we do need to bring back sine and cosine into this to talk about the idea of vectors in terms of magnitude and direction, where replace the word magnitude with modulus and direction with argument, and you have functionally the exact same thing as what we saw in the last section with complex numbers. Because if you wanted to, you could just factor out that magnitude, where what we have here is the vector v written in terms of its magnitude multiplied by its rotational position, thinking in terms of a picture like that for the vector, where that really does have the exact same meaning as looking at a complex number instead of being in rectangular coordinates in terms of the modulus and argument with sine and cosine. And to see a little bit more with this, you get a little bit more practice, we're going to finish this section with a, let's say, semi-applied example. So here we suppose a jet stream blows at 45 miles per hour at 60 degrees northeast. And we want to express this velocity as a vector in terms of I and j. So for this, we're talking about the vector of the wind being blown. We're talking about the direction and force of the wind, where we are given that magnitude, that velocity, as 45 miles per hour. So we'll just say that's 45 here. And we're told that it is moving in the direction 60 degrees northeast, which for us is represented as that direction 60 degrees, 6-0. Just to be sure that's not a 66. My handwriting's bad, but it's not quite that bad. Anyway, with that in mind, we can write our vector v using that approach in terms of the magnitude, which here is that value, 45 miles per hour, times cosine of 60 degrees as our horizontal component, plus 45 times sine of 60 degrees times the vertical component. I might have said vertical there when I should have said horizontal. Too many times saying the words vertical and horizontal. Those are the ones that are in trouble, not vector. But anyway, this is our setup here, where if we want to get that in terms of what we have normally in terms of a geometric rectangular type presentation, it's kind of like going from a polar complex number to a rectangular one. You just evaluate and push numbers around. As I evaluate and push values around, that just sounds incorrect. But we have cosine of 60, which we've seen a few times at this point, is 1/2. So we're going to have 45 times 1/2 as our horizontal component, plus 45 times root 3 over 2 for our vertical component, where push numbers in, pull numbers out. There's not a whole lot you can do with these because 45 doesn't get divided by 2 very nicely. Best we can do, if we want to be exact, 45 over 2i plus 45 root 3 over 2j. Better than nothing, but it's not that much of an improvement from what we had. Anyway, this is essentially the book on our basics for dealing with vectors. As I said before, in the next section, in 6.7, we're going to take this further and talk about some more advanced stuff here, starting with an idea called a dot product, which acts a lot like matrix multiplication, except now we're talking about smaller collections of things. But we'll see that next week.